Hey everybody, Rob Maurer here, and today we're jumping back into our conversation with James Douma. This is part two of this interview. If you missed part one, I'll put the link to that down in the description. This is from a couple months back, so we're talking all things neural networks here, all things FSD beta. This is before the FSD version 9 release, but I think all the topics are still relevant here, but just keep that in mind as you are listening today. So with that said, we're just going to jump right in to where we left off with part one. Well, I have tons more questions on neural networks. I think that's awesome background, but we probably don't need to talk about that all night. So getting to where we're at right now with like the FSD beta, I'd love to get a sense of your sense of the progress, where Tesla's at right now, how far they may have to go, how things are looking, how happy you've been with the progress, those sorts of things.
I did get a chance to ride in an FSD beta car, and I've watched a ton of FSD beta videos. I'm sure everybody, on this channel has.
Let's hope so. That's part of the homework.
Yeah, I was surprised at how good it was when it first came out. Like when the first videos I saw, I was pretty impressed. And I mean, this is speculation on my part, right? But I drove the early versions of autopilot, and they were pretty scary, right? And then I remember when we got to AP2, like AP1. When AP2 first came out, it was definitely a major regression. And it was a scary major regression for like 18 months before it was 18 months before it was clearly better than AP1. Not in every dimension. There were still places it wasn't, but it was clearly a win. That took a long time. And it's funny to think about how our standards have changed over with respect to this stuff, because people get quite upset about failures on FSD that seem to me like they were super common failures on early AP2, right? I mean, worse than that, like it would take you like right off the highway. Like you could do the freeway exit and it would happily go four-wheeling right down. I mean, you really had to intervene. You really had to pay attention, right? And it got better quickly, right? But there was no question that this was something where, like, when you were driving in the car, you were not going to pay attention to it. Especially in the beginning, you were regularly getting reminded that you needed to pay attention. When you got used to it, it was okay. But because like my sister got she got her Model 3 in 2018, super early on, right? And when she got it, I went down there to do the delivery with her. And like I took her out and put her on the highway, showed her how to use FSD and whatnot. And she wouldn't touch it for like 6 months, even though she heard me rave about how great it was, because it just took her quite a while to get over that. I mean, people, when you're driving AP, you're never out of control. Your hands, if you're behaving yourself, your hands on the wheel, the pedals are right there. Like you can intervene if you're actually paying attention in 200 milliseconds or something, right? And the car never, ever does anything egregious enough that an attentive driver can't intervene. I mean, that was one thing it didn't do. But you kind of don't have control, right? At the moment when you're not the person applying pressure to the wheel and the car has got it. And that just takes a little bit, the knowledge to become secure in the knowledge that you can instantly intervene whenever you want to, and everything is going to be okay. That's definitely a learning curve for people. And so people I know who came into the program later, actually, when it was a lot less scary, you definitely saw this, and maybe that was one of the differences. Like early on, it was so obviously sketchy, right, that you were never concerned that you were going to be lulled into into making some kind of mistake. But I can imagine that people later on were like, well, what if I get lulled into complacency and then something terrible happens? Mm-hmm. But so it's got that component to it, right? That you have to get up that curve. But so anyway, back on the topic of like what I thought when it came out, like I was expecting FSD to come out. It's an Elon program, right? Like I was expecting it to come out with all kinds of warts and that kind of stuff, and we were just going to kind of sort it out, right? And the first few weeks were just like going to be really, really rough, and they didn't do that at all. Like the kind of interventions that people were having to do and the frequency of interventions when FSD first came out, that seemed to me like what AP2 looked like, I don't know, 2 years after it was introduced, maybe. Yeah. So I had been worried for, I don't know, several months leading up to when FSD came out, because I'd been thinking man, if it's taking them this long to get to, the AP2
The major
first
regression
version,
stage. Yeah.
then that's going to be rough. And then, I saw how good the thing was. And my sense very quickly became that they're being way more careful now, that, they have a bigger audience. FSD is a much tougher problem. And like, you're turning left in front of, speeding traffic, you're going through stoplights and stop signs. There's definitely this potential for really egregiously horrible, accidents to come up. And I think they just dialed their level of caution up quite a bit. And we didn't see it until it was a lot more polished. And that's what surprised me, is it had a much higher level of polish than I was expecting it to when it came out. And of course, I was delighted, because that meant that, they had been making really good progress in the 18 months or so that I was sure they had been working on it, and I hadn't been able to see any of it. I did eventually get to see FSD networks. I've only been able to see one set, and it was an early version. But
did it look quite a bit different to you from like AK9? AK9?
Yeah, it's a total. Initially I thought maybe it wasn't as big a change, and then later I realized that they still. Like, my thinking about this has kind of changed. There's a lot of redundant networks in there right now, and I think that they're just running the old one because they can, right? It's just in there next to the one that they're actually using. So initially I was looking at it and I was seeing networks that were like, yeah, this looks kind of like the other network. But then I see there's a set of networks where the biggest networks are the networks, they take a raw camera image and then they process it into this very high dimensional abstract space, right? So they're basically doing that thing where they have this very large crystallized block of abstract knowledge about this, which has been generated through this back propagation process. So it's not designed to be understandable, right? It works, but you can't take it apart the way you can take apart a car engine. They're black boxes in a sense. They're not total black boxes, but it's kind of a black box. And then there's another network that basically takes that giant block of crystallized understanding from each one of the cameras, and then it combines them all together into one big block, right? And then there's another layer where like it basically has those blocks going back in time for the previous images, right? For one frame ago, the cameras are 36 frames per second. So, a 36th of a second ago, and 236 and 336, and going back maybe 16 frames or something like that. So it has a network that basically looks at the history of how this unified block has evolved over time. And then that thing generates a set of outputs which are used to drive. So it generates a set of outputs which are basically, here are all the cars, here are all the stop signs, here are all the pedestrians, and here's how fast they're moving, and here's what direction they're moving in. And here's what's on the other side of that bus, because it remembers that a pedestrian started walking behind. Like, it'll remember there's a pedestrian walking past a bus, or if you drive past a car and there's another car on the other side, it'll remember the car that it can't see right now on the other side, because it has this temporal knowledge. So all of those outputs, like essentially all the information that the handwritten code that actually drives the car, because so neural networks are doing all this perception. They're understanding what's going on around the car. And they generate a bunch of outputs, and the outputs are mostly things a human being would understand. Like, here's a truck, it's that far away, it's pointed in that direction, it's going 20 miles an hour, right? It's got a whole bunch of that kind of stuff. And there's code written by humans that sits on top of that, I presume, because I don't see it. I only see what comes out of the networks. But this is the kind of thing where people could write code that basically says, yeah, don't go any faster than the car in front of me, and don't cross the path of a car, don't pull in front of a car that's crossing my path. And if their light is red, stop. You can write all that code because you have all these perceptions from the neural network that that's my light and it's red, right? And I'm at an intersection where you can't turn right on red, or, it can figure all that stuff out. And they have literally thousands of these variables that get generated by the neural network. And there's code that gets written on top of that. And over time, as Andre said, they're gradually, like, that code that sits on top of it is going to gradually get lighter and go away, because the neural networks will be able to provide more. Like, at the end of the day, we'd like to say, yeah, take me there and don't hit anything and do it safe and, don't jerk, to have these very high level abstract ways of describing what we want the vehicle to do, and for it to have all of the cognitive constructs that it needs to actually do that. But right now, what we can get to is bus, car, pedestrian, fire hydrant, stop line, stops. Right? That's what we got. That's what we have right now. But as the networks get bigger, they're able to do these higher level things. Like there was the AP1 and AP2 networks had these fairly ugly failures where the car liked to see the lines on the road. And if you got into a situation where it couldn't see the lines, it would do kind of wonky things, because they basically, at that point, they had neural networks that were saying, well, here's that line, and here's that line, and here's the pavement, and here's the middle of the pavement, and that kind of stuff, right? And there was a piece of human written code that sat on top of it that said, well, if the line is here and the line is there, turn the steering wheel to this angle, right? If this is my position. Later, they had a neural network that basically said, go this way. It would describe this arc through space. So then the human code wasn't, if the pavement is here and the line is there and the line is double yellow, but there's not a curb, it wasn't this complicated chain of logic that would tell the car what to do. It was just like, follow that line that the neural network is popping out, right? It became much simpler, and it worked a lot better because the neural network could do this trick where it didn't have to, like, I loved some of the very first video that Green was able to generate out of the car was this video of this the path vector. The car's driving down this street in Paris, and it's in traffic, and there's this vector that's coming out, which is the line the neural network is telling the car to want to fuse, and it goes right through the car ahead, right? But it can't see the car ahead. But you could tell, like a human being, if you're on a busy city street, the road's curving to the right because the buildings are going to the right. You don't have to see the car ahead of you. Or, when you're coming to a T intersection, that you're going to have to turn right. Like, even if you're not at the intersection because there's a truck in front of you, you can see that there's a building blocking the way, and you're going to have to either turn left or right. And what you would see the neural network do is it would see that building and the arrow would turn right. It would, it would pick a direction. It was clearly looking at all the visual cues. It didn't need to see the pavement lines anymore, right? It could look at it could take the summation of the environment, and it could make that decision. And once it could reliably do that, once it can look over the crest of a curve of a hill and know that the road is going to the left because that's the way the trees are going, all of a sudden we started having much fewer like wonky steering wheel movements when there was a shadow across the road, or there was a crack or the lines weren't painted on the road, or something like that, or something just happened to interfere. So as neural networks get better at producing these more simple to understand from a programming standpoint and more kind of reliable, more generalized perceptions about the situation, it's going to get a lot easier to do things. You don't, the human doesn't have to write if there is a pedestrian and they are facing left and they are standing this close to the curb and they are looking at their phone, do not drive past the pedestrian. Instead, they can just, don't drive past pedestrians who might step in front of the car, right? That's a much easier construct to be able to write a piece of code against.
And that's where Tesla is roughly at today. And it's slowly increasing over time. And I guess better stated, do you see that increasing now with the FSD beta, or is that kind of what you're saying would be the next step beyond that?
Well, there's this arc of progress, and AP was over here and FSD is way down the road from where AP was. A good question is, like, how far do you have to get along that curve before it's good enough for, robotaxis or summon, or it's my car, can I take a nap and expect to wake up at my destination? There are thresholds like that. And in a sense, we don't know at what point along that arc that's doable. And I would argue right now that the biggest unknown about when FSD is going to be done is that we don't know how far along that curve you've got to go. I'm pretty confident that Tesla can look at their progress and estimate, well, at this rate of progress, we will have this level of functionality at this point in time. What they can't say right now is, will that be good enough to do this job? Because the failures are these long tail events where you need a certain amount of data. You need a certain amount of experience with a system at a certain level of polish before you're confident that you actually understand how it responds to rare events. And I think they probably gather that knowledge on some kind of time delay. So they're probably pretty confident about where they were like 2 months ago or 3 months ago. And they might be less sure about exactly where they are today, right? And you still like don't really know exactly where the endpoint is. But as a human being driving the car, and I felt like I was learning a lot about Tesla's autopilot and by looking at the neural networks. And I certainly got a sense of how much control they seem to have and what kinds of things that they're playing around with. But ultimately, I found that the way to understand their rate of progress, it was actually to get in the car and just drive it around a lot, right? Drive it in lots of different situations. Because if you drive it a lot and you drive it over a long period of time, you'll get a very strong sense of what the rate of progress is. And I think that Elon's conviction about their eventual success, or Andre's conviction about their eventual success, is not because they're looking at these graphs of incidents in various categories. And they'll have some graph of like this kind of intervention is going down with this frequency, and it'll be this small at this point in time. I think they can say that kind of stuff. Like they've got curves that say that. But much more than that, like what's the new intervention, which is going to crop up that we don't know about now, which is going to be really important in 3 weeks. But they can drive the car and they can get the general sense of how the experience of driving the car, the amount of attention that you have to pay under various circumstances is being relaxed. And they can see, that there's an end to this process where they get there. And I haven't driven FSD, but I've driven autopilot on the highway a lot. And I definitely had a good sense of where autopilot was going to be like 3, 4, 5 months ahead of time after I'd been driving the car for a couple of years, right? You could just look out and you could tell like where this arc was leading. And I think that's more than the numbers. Like that's the basis of their belief that they're going to get there in a particular time frame. A year ago, I thought we were going to be there. We were going to be here now, though. So there's plenty of opportunity for people to be Pollyanna-ish about it and be wrong. And this whole field of study is no stranger to that, right? Right. Chris Urmson famously, I think he stood on stage at one point when Google was still doing self-driving cars. And he said he was quite convinced that they were going to have self-driving taxis before his child was old enough to get a driver's license. And I believe that event passed 4 years ago or something, right? So people in this space have always felt like we were getting really, really close. And that's been true since the DARPA Grand Challenge was a shocking event because they did the DARPA Urban Challenge. DARPA did these grand challenges. DARPA is the Defense Advanced Research Projects Agency. And they did they sponsored these contests where people could come and enter a self-driving car to meet some particular challenge, and there would be some prize money, millions of dollars or whatnot. And as you can imagine, lots of tinkerers got together, but lots of universities would put together a team and they develop a car to do this. And the first couple of challenges were just like drive in a straight line across the desert and don't hit anything, right? And it was ridiculously simple things, and they couldn't do it. Like it was. The first couple of years were just like the problem seemed really simple. And then they finally had 2 cars complete the challenge. Like 1 year, I think it was the second or third year. People made good progress, right? But you could tell it went from pretty simple things to like really complicated solutions with big teams of people and lots of money going at it. They were definitely going for bragging rights. And then 2 years later, DARPA was like, oh, we're going to do one in town. And, the cars will have to drive, from point A to point B and observe all the traffic laws. And they have to interact with other vehicles, driven by stunt. They hired all of these, professional drivers to drive around to create traffic and that kind of stuff. And they would have to they went to this Air Force base, this abandoned Air Force base, which is basically like a small town. So they had this whole small town to themselves, and they would have these missions where you had to go to the grocery store and pick up this box, and you had to go to the movie theater and park in a spot, and and the teams didn't know what these things were ahead of time. So I went to that with a bunch of friends, because the public could just come and watch the contest unfold. And everybody was expecting it to just be a disaster, because we remembered, a few years back, they were just trying to drive in a straight line in the desert, right? And it was not pretty, right? And even the year when they succeeded, most of the teams failed horribly, even in the year where a couple of teams faded. 5 teams finished. Like, it seemed like this impossible goal. It was just like, what were they thinking, DARPA, when they set this challenge, right? And, they had 20 teams show up, but 5 people did. It ended up being a time race, right? At the end, it wasn't like, could you do it? It was like, could you do it faster than the other guy could do it? It was just shocking. And I think everybody in the field who went to that event came away from it like, oh my God, we're going to be there in 3 years or 5 years. Like, everybody I was talking to is like, oh yeah, 10 years at the outside. Like, there's no way it's going to take 10 years now to do that. That was in 2006.
Womp womp.
Yeah, but that's what it really seemed like. I mean, you could watch the Carnegie Mellon, you could watch that Carnegie Mellon car coming in. The cars had personalities. You could tell, the Carnegie Mellon had this super aggressive, it totally seemed like a 24-year-old pickup truck driver who was like annoyed that people were making him wait at the light or whatnot. And you had these other ones that would be like grandpa, right? Driving around, they were super timid or whatnot. But I mean, the ease with which you could anthropomorphize the vehicles as they were doing all this stuff really made it feel like, the field had tapped into that essential vein of competence that they just needed to follow that line long enough, and they were going to get there. I was certain that it wasn't going to take 10 years. I was dead certain. Like, all my acquaintances were quite confident. People, the guys who'd been in the robotics field forever, who were always like, oh, that's 1,000 years away. They were still saying that, right? Yeah. Of course. But we're like, oh, you always say that, right? So we just wrote them off. But yeah, 2016 came, that was around the time that Chris Urmson thought that Google, that Google would have the car working. And man, Google, they made great progress. They bought some of the research teams, and they funded them well, and they really went after that thing. But they did a thing fairly early on where they decided they were going to get really conservative about how they approached it. And I think that really cost them a lot of time. And even if they hadn't done that, they might not, I don't know. They'd be ahead of where if they were a little more aggressive, they'd be farther. They got 600 cars in Chandler, Arizona, driving people around, and they work, right? People summon them. They mostly drive without people, despite Rodney Brooks' complaints. He's a famous roboticist, right? Who's famously skeptical about self-driving cars' ability to get there anytime soon. I feel like Waymo's made really good progress. And while I think their technique is obsolete now, because they have been, I think if Waymo had guts in 2017, when it was really clear that the ImageNet results were there, they would have changed tactics. And I'm shocked that in basically 2015, 2016, Elon decided, yeah, neural networks, they're going to win. We're going to do that. I'm all in. We're going to put all the equipment in the cars, and we're just going to start writing software, and eventually we're going to make it work. It's just like, man, that's got them so incredibly gutsy. It's just amazing. Like, I think it was right. And if Elon had called me, I would, yeah, I'm all in. So do it. It's the right answer. But the rest of the industry, they were not in that place, right? They were, and Waymo had some experience, or I mean, they were Google at the time. They'd had some experiences with like, they did a thing where they got all these Lexus RX 400s and they put lidars on top of them and they put a bunch of sensors in them and they wrote some software. And then they, I mean, the systems were good enough. People would like take them home, get in the car, tell it to drive home. It'd drive all the way home. Right. And they gave these to some employees and they had a camera in the car monitoring the employees and something. And they concluded that people got too comfortable too fast. Like, I don't know exactly what happened because like, there's the story that they tell. And it really, it always seemed to me, maybe I'm just misreading this, that their reaction to what they claim to have recorded just seemed like it was way too strong. So it could be that we're a Fortune 500 company. We have to think of our reputations, just big company conservativeness. It could be that they thought, well, we're going to get there pretty soon anyway. Like if we delay it a year or two so that we can be super, super careful and we can definitely be the good guys and nobody ever gets hurt. Yeah, that's worth doing. Okay. I could see people doing that calculus, but the consequence of that was the consequence of that, plus the fact that it was farther away than people thought it was that, here we are, it's 2021 and Waymo's got 600 cars that can kind of drive people around Chandler, Arizona on its own. And the reason I say kind of is like, technically, I think they can do it, but I do not get the impression that they're at a stage where they're like, yeah, let's start building cars. We're ready to roll it out to 300 more cities. Right. It's not that kind of thing.
And if they were, they'd be doing that aggressively because of Tesla and because of the rest of the competition in the market. Like there's an incentive to try to start rolling things out if they feel like it's close, and they haven't done that yet. Yeah,
I think Tesla is probably putting a lot of pressure on them. I mean, they've been in a bubble for a really long time where they could just work on the problem. They didn't need to really care what the public thought about it. They had the funds that they needed and they could just treat it like a research problem, right? And just work on it until they were satisfied with it. And now I think it's setting in that the window of opportunity is closing. And I mean, my guess is the window of opportunity is closed. I can't see them scaling fast enough that the tsunami of FSD doesn't run past them, which I don't think necessarily means they can't be successful. I think it does mean that they are not going to dominate this market. Like Tesla's definitely going to dominate it. And the question is just how much air is there in the room for everybody else?
So obviously the main problem with Waymo's approach seems to be scale and data collection. Andre talked about that, the sort of the loop of the neural network process is like make the predictions, scale the mispredictions, collect all those, backpropagate, like you talked about, and then retrain the network through that process, and then do it all again as many times as you can, and slowly weed out those errors through like slowly tweaking the weights, maybe make some adjustments to the neural networks themselves. Is your sense that Waymo just can't do that process or can't do it as quickly because of the lack of data that they have from only having like 600 vehicles?
I think there's a chicken and egg problem if you want to do Tesla's approach, right? Which is you got to build the fleet way before you have the platform. But it's only a chicken and egg problem right now because building these systems is getting easier over time. So the degree, like how many cars you've got to build and push out there, how much data you've got to collect and how long it takes you to get the system working, those numbers are all going to get smaller over time because the techniques are getting better and the computers are getting faster. So the more horsepower you have in the cars and the more horsepower you have in your data center, the more you can shrink these other dimensions. So at the point in history we are of the development of the technology, you need a lot of cars in the field to gather enough data to be able to to crack this problem in a reasonable amount of time. And that means you're going to front a tremendous amount of hardware that now, of course, the amazing thing is that Tesla's getting people to pay for this.
Right.
They're getting people to pay for it and they're getting people to drive around and test it for them. It's amazing, right? But if you're not a car company, you can't do that, right? Like I don't want to say that there's no solution for Waymo or Cruise or whatever to try to replicate that. I don't think they're going to try to replicate it at this point. I think they both see the light at the end of the tunnel on the approach that they're on right now, and they're going to run toward that light, and they're going to try to lever that platform, and that long term, the path to success for them is to gradually crank down the sensors on their cars, refine the package down to where it's not as dependent on the maps and it's not as dependent on the expensive sensors and that kind of stuff. And essentially, in the long run, they're also pretty much just cameras and cheap sensors on relatively inexpensive robotaxis that have like a 15 cent per mile operating cost, right? Electric vehicles, relatively small, lightweight. Your sensors are pretty simple. You're extremely computation heavy. I think there's a smooth path from where they are to that. Like they can get out with the sensor suite that they have, as long as there's enough market for them, right? One way that the market could close for them. And I've been doing this thing where I was doing these spreadsheets with Dave, sort of thinking through. We were doing some of these today on an interview, just like imagining the possibilities. One of the things I did is I took ARK Invest model all apart yesterday. I just like went through it and to figure out like how all the bits and pieces work and what all the sensitivities were. And we did an episode about that today. But in working through that thing, I ended up working through a bunch of different scenarios. So I was at that, and I started thinking that, so ARK's got this thing where like robotaxis can drive 100,000 miles a year, right? Paid miles. And then you've got these other miles that you're not getting paid for. And they have a span, and 110,000 is their median number. And 110,000 miles times a million cars is 110 billion miles, right? Okay, so Americans drive 3 trillion miles a year. That's a lot, right? But if Tesla makes, if they triple their production output once Giga Berlin and Giga Texas come online, or quadruple it or something like that, and then we go 1 or 2 more years after that, we're starting to talk about the United States having enough miles that Tesla could supply enough robotaxi miles to actually take like half of them. A huge fraction of all the driving miles that there are, right? When we get into that era, as soon as you've got more than a few 100,000 robotaxis on the road, the price is going to start rapidly coming down because they're just competing with one another. And the one scenario in which that doesn't happen is if there's no competition, because if Cruise is in that city and Waymo's in that city and Tesla has these other cities and they're not really head to head with one another, they could, if they wanted to, if it was in their business interest, they could keep the price high for a while because they're effective monopolies. They're each a geographic monopoly. But if they start competing with one another, the price is going to start coming down. And as they scale up, in order to be economically viable for more use cases beyond the use cases that people use taxis and Uber for today, the price has to come down to make those. So where does that number go? Where can that number can go really low? That number could go to 25%, 25 cents a mile, right? It can go crazy, crazy low. But once you get to $1 a mile, or once you get to 50 cents a mile, that's probably a really dramatic increase in the number of miles that people would be willing to use this for, instead of taking a train or a plane or driving their own car or whatever. Like, it'll pull traffic from those other things. So if Tesla scales fast enough that they start driving that price down, other competitors could. This is the scenario, I'm just outlining the scenario in which I think other competitors fail, because I think there's lots of potential for success in general for people in this space right now, for more than one person to succeed, more than one company to succeed. I think the failure scenario is if Tesla manages to saturate the market and start driving the costs down. Because once you get to a certain point, you have to have a lot of Tesla's other advantages, not just FSD in a relatively inexpensive car. You got to have, the cheap drivetrain, the batteries, the ability to crank out large numbers of cars at reasonable margins at really, really low prices. Like that starts being the difference between a profitable and a not profitable robotaxi. Now, I don't think we start to get into that zone until we're talking about like 1 million in fact, it'll be more than 1 million, because we'd be talking about the US and Europe and some of China also, which is that's a lot of, the US has hundreds of thousands of rideshare vehicles and taxis. And then, Europe is double that. And then China is a lot, it's another tripling on top of that. So it's 1 million plus vehicles in the worldwide fleet, but you could see geographic locations. Like if for instance, the US turned out to be the really profitable market, or I don't know, Germany turned out to be the really profitable market, you could see a bunch of players pouring into those markets, right? And saturating them pretty quickly, driving the profit out of the profitable market and then going to number 2 and 3 and so on. It could happen. But it's going to depend on how long it takes Cruise and Waymo and other competitors to scale, and how long it takes Tesla to get to scale. The thing is, Tesla's just going to keep pumping those cars out there, right? And when FSD is going to transition from like not viable to saturating the fleet over 12 months or something. I mean, there's going to be a window where it crosses, and then a couple of big market regulators will approve it. And pretty quickly they'll be able to deploy those vehicles. And when I work the numbers on robotaxis, the profitability is high enough that I think it will be able to attract the vehicles, even if Tesla doesn't own those vehicles. I was looking at one of ARC's scenarios. Dave had some more conservative numbers he wanted me to drop into the bull scenario, and then we were talking about, well, would 20% of people put their car in the fleet? We had a particular number, and on ARC's expectation for how the price changes with the number of robotaxi miles, it was, you've got a robotaxi, it's 110,000 miles. And they're assuming the average robotaxi can do 110,000 miles a year, and they had $1.10 as the rate at that for that size fleet for those many things. And I was thinking, and we had a 30% take rate in the model for or 30% platform fee, right? So the user keeps 70% of it. So that's $90,000 a year of gross billing for your Model 3, right? Okay, so you've got a Model 3. And you can keep it in the garage, or you can get $90,000 a year for letting other people use it when you're not 20%. Using it, right? And I was like, more than 20% of people might take that deal. I mean, that's not what the scenario ends up looking like, right? Because, some combination of the upfront cost of FSD plus the number of people who are willing to take the deal, plus whatever the current bid, going rate for miles is going to come to some kind of equilibrium. We're not going to get this, oh, that's a total no-brainer, but why isn't anybody doing it? Well, those situations won't occur. If it's a no-brainer, people will do it and the numbers will change. But it's like it's a nuttily profitable business for, pretty straightforward set of reasonable assumptions. And so what I take from that is that it really is kind of like the software's the limiter, right? And, if the software is not ready in a year, 2 years, right? I think, my hope is to see them have the system working this year, technically, like it's solid, not perfect, but solid. And then be accumulating data, and by the end of next year, right, start convincing some regulators to let them turn it free. Like, that's a pretty optimistic schedule. Like, I don't feel pessimistic on that. I mean, it's not an Elon schedule. But you think about that, and that's 4 million Teslas on the road at that point, maybe 3 million.
Yeah.
So that's
maybe 1.5 million in the US.
A million or two robotaxis.
So
that could be deployed.
When you guys were walking through that math, like, what did you get to the number of how many robotaxis you think there should be based on that 3 trillion?
Okay, so the point of that video I was doing with Dave was that, like,
well, if it's going to be Dave's, we can leave that for that if that's the video. I'll steal Dave's content.
The point is, there's no number. That's the short answer is there's not a right number, because models don't tell you what the number is. Models, basically, you put some assumptions in and you do some math, and they basically tell you, if all your assumptions are right, this is the number that makes sense, right? That's what you get. But the thing is, you don't know what the inputs are. And, we spent some time talking about, like, why did ARC do a Monte Carlo model, right? Why was that the right thing to do? What is it getting you in this situation? And it does get you a very important thing, which is that as soon as a model has more than a couple of parameters, setting them by hand is really tough, because you might think you're setting it a little conservative, but combinatorically, because of the way the math works, like you're going just a little conservative on a bunch of numbers. And the result of that, if you've got 10 parameters and you set each one slightly conservative, you've got an absurdly conservative outcome because of, if you assume a certain statistical distribution of reasonable numbers for all those things. So the problem is once you get more than a few parameters that you're not sure of, because ARC, unlike these other guys, they're looking 5 years down the road, right? So the distribution of possible reasonable inputs for all their parameters are quite a bit larger. So if you actually want to understand what's the reasonable distribution of outcomes, you have to take your human intuition about what's a slightly conservative number off the table, right? Instead, what you do is you define a distribution for your input parameters. You let the Monte Carlo model juggle them all, and then you look at the distribution of outputs, and that has a lot of flaws, but it solves one really important problem, which is that humans guessing numbers have a tendency to sandbag one way or the other. You just do, right? Because you're like, you do the analyst thing where like, I don't want my number to be too high. I want it to be okay, but I don't want it to be too high because then I'll really look like an idiot. It's okay if it's low. So they guess a little low, right? Like if that's your bias, but you guess a little low on 10 parameters and now you have a ridiculously low model, right? And that might be part of the reason why analyst numbers seem so low and keep coming out really low because maybe they're not Monte Carloing their numbers, right? They're trying to be a little conservative, but what happens is the math of the model takes slightly conservative assumptions and turns them into an absurdly conservative outcome. Because that conservative, you multiply them all together,
Right. Exactly. That makes sense. I'm glad you're talking about the Monte Carlo because I did an episode earlier this week and I was a little bit critical of it.
Was
so
a good
it's
episode.
It's nice to have that other perspective though. And like, I understand there's definitely some value to using a Monte Carlo. I think a lot of people sort of misunderstood that I was saying like, oh, this is just completely worthless. It's not that. It's more just that I think it makes it more difficult to kind of explain what ARC is talking about because you really have to understand the model. You have to understand like all the different inputs. And frankly, people just don't take the time to like go through that spreadsheet and like look at all the parameters, understand, the range of outcomes and things like that. I think it's just a little bit easier to start the conversation with a forecast and then talk about whether things are conservative or whether things should be increased and then kind of work from there.
If you want
but
a narrative,
it is valid to if you're trying to get the range of distributions that, there is some validity to using it. So I'm glad that we're having this conversation now.
Yeah. There's not a simple right way to do this, that you get different outcomes with different things. But if you do have a bunch of variables that have a pretty big range, your intuition will really hammer you because people really don't. You say, well, let's multiply 0.98 against itself like 5 or 6 times. And you ask somebody, well, what is that number? And, if you're working on your intuition, you're going to be way off, like how low that number is. And that's what happens is like you do a 98%, you're just 2% conservative on 11 parameters that all get multiplied against one another, right? And now you've thrown away half of your you got a 50% error now.
So basically what you guys came out to is, there's just a range of possibilities, no right number. We'll see what happens.
Yeah. So I ended up doing this because we did a modeling thing earlier and people were like, oh, show us your model. Oh, no, wait.
Too soon.
That's the wrong, no, it's not too soon. It's like, models are garbage in, garbage out, right? Like if you don't understand everything that's going into that model, you don't understand what that number is coming out. Like exactly. Because these numbers are predictions under a set of assumptions, and you only understand the prediction if you understand the assumptions. And unfortunately, you give people a model and they look at that last price and they're like, oh, that's his guess. And I'm like, no, that's my guess under these assumptions. But you can change all the models I have. They all, I've got I can take the same model and I'll make 20 copies of it, right? And I'll put different sets of assumptions for different stories in. And this, looking at the same model over a bunch of different things, you get a sense of like what matters and what doesn't matter. And I actually started with ARC's model on Dave's thing because I thought it was very interesting to do the sensitivity analysis on ARC's model. Like you go through and you can go through they got tons of inputs, right? And you go through and almost every single number you change, it doesn't change the stock price, right? You can change it 10% or 20% or whatever the deal is. And there's like 3 or 4 numbers in there that just hammer the stock price, like, right? So, there's 10% of the numbers are all of the influence. And all 10% of those numbers, they're in the FSD model, right?
Right. Yeah, totally makes sense. Yeah, it's super interesting. I'm just trying to think if there's anything else from here anything on your list that
we talk about.
Yeah.
Yeah. So the FSD NNs are quite dramatically bigger and more refined and more sophisticated. As far as I can tell, everything that Elon has alluded to being in there is actually in there. There's some stuff I can't see. There's a recurrent neural network or transformer, which is used for stitching up the time-wise frames. And I think they're doing that in a GPU because I can't see it. Yeah.
So when we're talking about the inputs, that's, I guess, one of the questions I had from before. Elon has talked about a lot about making it surround. So taking all the images, merging those all together, and then having it time-based. Are they doing that through a neural network, and then that's like sort of one of the middle layers, or is that where it's exact, like from the onset, I guess?
Yeah. So basic structure is all the cameras go into individual networks that basically generate, a chunk of output specific to that camera. The outputs from those cameras, they go into a block that synthesizes them all together into, say, a 360 view, right? In a sense, it's not really a 360 view because, as far as I can tell, that network, it's not trying to make them spatially coherent. The output of that network is not an attempt to make a spatially coherent thing. It does fuse what all the networks know about what's going on about the car. It's not distributing it in a spatial manner, right? That's kind of, sort of human readable, if you will, right? Then after that, it fuses over time. So they build these, all-encompassing 360 sets of perceptions. And then they combine them over time, and they do this with another technique. You can't do this easily with a convolutional neural network, and I think that's why it's not running on the chip that I can look at. And they're doing some of that on the GPU. So the output of that is a bunch of outputs. But one way that I like talking about them, there are these bird's eye view nets, BEV nets. So the functional output you've seen the outputs from the AP1 style networks where, you have a camera view and you got a car and it's got a little cube drawn around the car, and there's little cubes around the pedestrians and they have little markers on them. Like this one's going that way and this one's going that way. And, lines for the important features on the roadway. And, and actually, if you really drill down into it, it's labeling so much stuff that if you put it on the display, you'd see nothing but lines. Like there's just like so many things that get labeled in an image. But that was all in the camera view sort of frame, right? So now the output of the ultimate thing is like if you have God's eye view and you're looking down on it from above, you have this unified view, which is it's the consensus of all the cameras for everything that's going on around the car. So, one of the things that you used to get with a truck, which I don't know, you might still see this in your car. You stop at a light and a big truck pulls alongside you. And, a lot of times it morphs into two trucks as it's going by, and then it becomes another single truck. And part of the reason for that is because it's moving from the field of view of one camera to another. And the cameras, the code, which is stitching those cameras together in AP2, it's looking at those things and it has to say, is this the back and front of the same truck, or is this maybe two different trucks, right? And it's actually for a big object that's really close to you because it just like sort of extends out of the camera's field of view. The system can have a hard time making that decision. If it's properly fused, like that won't happen, right? The big truck will drive past you and it'll be one truck the whole time, right? It won't get a lot larger. It won't morph into a pickup truck halfway as it's passing by you because it's getting a consistent perception of that, even as it transitions like across the field of a camera and into the field of view of other cameras. And this is something you see on FSD. You look at the FSD videos and you see cars going by and they don't transform into other cars as they pass through the intersection or whatever the deal is, right? I mean, you can see a car that stopped at a light and it sees like a truck or it sees a motorcycle, do a left turn across it. And you'll see a little bit of jitter, like it won't be a perfectly smooth path because the network will have a certain amount of uncertainty, but it'll be continuous and you don't see like the really crude dislocations that you see now. So I think, so that's what I see in the neural networks is I see them generating these BEV nets. right? That's a major category of output, and it's a major kind of structure that they're using in the neural networks that did not exist and could not exist because the GPU and the AP2 and AP2.5 is woefully incapable of doing these kinds of things, right? And I'm very confident that FSD is actually using that because I can look at the environmental perceptions that are put on the screen, and they're completely consistent with this change in the network, and they're inconsistent with the networks. And like I said, that there's AP 2.5 like networks that are still in there also, and I think they're getting them for free. And it may be that they're using the AP. There may be things that AP 2.5 networks still do well, and they're trying to transfer knowledge, or they're comparing the two. Maybe the 2.5 is running in shadow mode in the FSD, and what they're looking for situations where one of them does, where the AP 2.5 is still outperforming in some situation relative to the other, because then they can take that back to the data center and they can figure out how to transfer that knowledge from the old network or the old way of doing things into the new one. But I think the dominant mode that they're using now is they're synthesizing all the cameras, they're making them coherent across time. And then out of that structure, they're generating a holistic understanding of all of the outputs that's a little bit of an exaggeration. There's probably still a separate windshield washer network, right?
Oh gosh. Speaking of AP2, yeah.
Serial things. Yeah. But
is there anything that you're seeing, or maybe not seeing, is there anything that gives you pause of like Tesla may not actually be able to accomplish what they set out to do here, whether that's from like an input hardware perspective, compute perspective, anything else?
No, I there are things that give me pause, but they're things I imagine that could possibly happen. They're not evidence that what I see. Like I said, I have this experience, and other people in the self-driving space, they have this experience of like feeling like it was so close for so long, and yet the new things kind of keep popping up, and so there's the fear that there are phenomena that we're not seeing clearly yet, which will have to be dealt with, and which will take time, and which will delay things. But like that, those are the kinds of things that I think are serious candidates for there being a delay. At the end of the day, there is this irreducible kind of gut component of it, right? Because you have to speculate about the unknown unknowns, right? And the thing about unknown unknowns is they're unknown, right? All you can do is speculate. You can't know that. But I'm quite optimistic that it's going to get there, and it's going to get there relatively soon. And relatively soon being like, man, I've been waiting 16 years. I've been waiting for this, like since I went to the DARPA. Actually, I was following it for a long time before the DARPA challenge, but like since DARPA challenge, I was certain that it was right around the corner, and I'm not alone there. A lot of people feel that way.
And if you had to put a stake in the ground today, you'd say end of next year, that would be your best guess.
Yeah, I think
with
that's
a lot of appropriate disclaimers around it, obviously, but
the unknown, it's way easier for weird unknown stuff to push it out than it is to pull it in, right? So there's kind of an asymmetric error function on that, unfortunately. Like my best guess, that is my best guess, right? But the error is asymmetrically distributed, right? My 50% probable error on the near side is it comes in 3 months. My 50% probable error on the far side is it moves out a year, right? So.
Right. Yeah, that makes sense. All right. Well, I think that's probably as good a spot to leave it as any, but thanks for taking the time, James. I know this was a long conversation, but super informative. And I'm sure
chunk it into 5 things and spread it out over 2 months.
This is going to be like 2 weeks of episodes.
Okay.
But yeah, I'm sure we'll talk again soon.
I'm really bad at summarizing things. I mostly don't talk to
that's
people
just
who aren't
not
in
true.
space. I feel like the neural network explanation went kind of long. I tried to
it's a little bit long, but
it's like with my mom.
It's I like how we started it off that way, and then it was like a 40-minute conversation. But yeah, I'll try to chop it up a little bit.
She's a science fiction writer, but she's not technical, right? So so my conversations with her are frequently So what would happen if X, like, or could androids do this? Right? Or, like, and I'm like, okay, let's have that conversation. It's a fun conversation. You got to talk to someone with you.
Yeah.
So,
yeah, that is.
But yeah, we've done the self-driving car thing a couple of times. I don't think I'm getting through to her. But,
yeah. Well, I don't know that FSD beta will help with that at all, but
and we'll see.
All right. Well,
how are you enjoying your car?
Wrap it up there. I'm loving it. All right. I hate to cut it off in the middle of that, but that's kind of where our conversation wraps up. I'll definitely share my thoughts on first few months of ownership now. I guess, over around 8 months now of ownership of the Model 3. I'll share some thoughts on that in a separate video for sure. But thank you all for listening. Make sure you are subscribed and signed up for notifications. You can also find me on Twitter at Tesla Podcast. And I'll see you next Monday, and we'll get back into the news. Remember, this was recorded a little bit early. We'll get back into any news that we missed over the last couple of days on Monday.